Hello, my name is Alberto Roper Pol. I am originally from Ibiza, a small island in the Mediterranean Sea in Spain. I did a bachelor and a master in aerospace engineering in Catalonia, and after that I moved to the US to do my master and PhD at the University of Colorado. Already during my bachelor, I started becoming very interested in physics and mathematics, and I actually studied a bachelor in physics. And it was during my PhD that I had the chance to start studying a very interesting topic about the production of gravitational waves in the very early universe. I have now recently gotten an Ambizione grant by the Fonds National Suisse to work on the topic, which consists on exploring the early universe with gravitational waves and primordial magnetic fields at the University of Geneva, in particular at the Département de Physique Théorique, at the Cosmology and Astroparticle Physics group. During this project, which I will be starting in February of 2023, with a PhD student that will be joining also for the position, we will be studying sources of gravitational waves in the early universe. So let me first explain what are gravitational waves. For example, when we have two black holes that are orbiting around each other, while they are orbiting and then they end up colliding, they produce perturbations in the geometry of space-time, which is around them. These perturbations of space-time, they would propagate until they reach us, and we are able to observe this, for example, with some recent observations. These gravitational waves, they were prescribed for the first time by general relativity of Albert Einstein in 1916, and it has been very recently that we have been able to observe them for the first time, back in 2015. These are not the only sources of gravitational waves. We also expect gravitational waves to be produced during the very early universe, so during the first fractions of a second after the Big Bang. During my Ambizione project, I will be investigating sources of such gravitational waves precisely during these first fractions of the universe. This would allow us to explore the early universe at its highest energy scales in a different way than what we can do with current astronomy, because the first astronomical observations that we have date from around 300,000 years after the Big Bang, while the generation of gravitational waves would allow us to probe the universe at much earlier times. In order to do this, we would need to go to space, which is planned to be done by the Laser Interferometer Space Antenna, or LISA, which is a space-based mission that is planned to be launched in the 2030s. With these observations, we will be able to study some open questions in physics, as for example, what is the origin of matter instead of antimatter in our current universe, as well as, for example, the origin of primordial magnetic fields that can be generated during the early universe, and they could still be observable at present times in the larger scales of our universe. I would like to thank the University of Geneva for hosting me, as well as the support by Professors Antonio Riotto and Chiara Caprini that have supported my application for this Ambizione project.